Hi everyone. In this lecture we'll try to understand about the PySpark architecture, like how PySpark is working as soon as you run your PySpark job. So PySpark is basically work in the master slave architecture only. So it is a collection of nodes. Let's say you have a multiple nodes are there. Let's say this is my node 1, this is my node 2, this is my node 3. And among that, one node will behave like a master node and rest of the nodes will behave like a worker node. So let's say this is a worker 1 and this is a worker 2, and we can have one more worker node which is a worker node 3. Now you write down the Spark application, and as soon as you write down the Spark application and you try to submit that Spark application, what will happen? That there will be a driver program. There will be a driver program which will be running from the master node. So what this driver program will do, it will create a Spark context. We called it as a Spark context. So in a layman word, what I'm saying, like as soon as you submit your Spark application, there is a person and that person name is driver. He will create one Spark context. So this is like, entry point of your Spark application. Just get started. So whenever you submit your job, Spark job, that will, your application will get started from the Spark context only, and then your rest of the work will get started. Now when you submit your job, let's say you have a file and you have a huge amount of files are there in which multiple data is there. You want to process that file by using Spark technology. So Spark context is the entry point. Okay, that we understood. Then later on, to run this application, means to read this file, you are going to read it, then you are going to perform some of the operation on it, like transformation and actions. So when I say a transformation, maybe you are trying to filter the data, maybe you are trying to write a file. To do all this operation, we need someone who is going to negotiate the resources, who is going to provide the resources. Provide the resources means like your memory, CPU and all those things. That will be done by using one more component. We called it as a cluster manager. Now in most of the cases, this cluster manager is a Yarn. Yarn is a cluster manager who is going to provide the resources. Now as soon as we got the resources, okay, let's say for this application to run this job, we got the resources. That job will be running on your worker node, and on every worker node to run this job, we will have executors. But executor is running under a JVM. It is like a platform which is available to execute that job. But who is going to execute that job? Actually, this executor will have a number of cores. Who is going to do that? The number of cores. The cores is like, let's see that these are the people who are going to actually executing this job on the local node or on the worker node. So every node will have a number of executors, and executors will have a number of cores. We can have multiple cores over here. So assume that I am having 2 cores. It means this job on this worker node will be running parallelly, and that is a 2x times. So there are 2 people who are working on it. Again, here also we will have an executor and their corresponding cores will be there. Core number 1, core number 2. Here also the executor will be there and corresponding their cores will be there. And every core will perform a task. Every core will perform a task. So basically here what we have understood, whenever you are submitting your Spark application, your Spark architecture works in the master slave architecture. On the master, you will have a driver program which is creating a Spark context, that is the entry point. Then as soon as you submit your job, you need someone who is going to do the monitoring of your job, do the resource management. That person we called it as a cluster manager. Then as soon as you are submitting your job, that job will be executed by the executors which are available on each and every master node. All executors will have cores to execute that task. So core is basically the number of cores will define that how your job is going to run parallelly. That is all depending upon the number of cores. So we should have a number of executor. In Databricks, the number of executor is always 1 to their local node, to that worker node. But in the other platform, we can have multiple executors, and multiple executors will have multiple cores which will do your multiple tasks. And that's how your PySpark application works. If you think that you are able to understand this question, this is very important. So you can reach out to us for the training purpose also. We can help you with the real-time Spark training along with the AWS and all. Okay, thanks. Bye-bye. If you want to learn about more about this big data technology, PySpark technology, you can reach out to us. Our training details is available in the description of this video. Thanks.